Hi devs, Artur from vlayer here. Today in this video I would like to show you web proofs, the solution for bringing real-world data straight into your smart contracts. In this video I will show you how you can capture web data using vlayer browser extension, how to generate a zero-knowledge proof out of it, and finally how to verify it inside your Solidity smart contract. The best part? You can prove specific properties without revealing sensitive information. So we're gonna have a privacy by design. Sounds interesting? Let's start building. And in order to start, just go to your terminal and type vlayer app. It's a command that downloads the latest version of vlayer CLI. Then once we have it, we can initialize a new project with specific template. We're gonna use a simple web proof in that case. And once the project is created, I will just enter it and build the smart contracts using Forge build. Next, we will install dependencies and start our local environment. Just head over to vlayer directory, run ban install, and then ban run devnet app, which will start the local blockchain in the terminal in the back and some extra services needed by vlayer. And finally, we can start the local web server that will run on localhost 5137. This link should already work in your browser, but we'll get back to this in a minute. So now let's maybe examine how to configure a new web data source. In this example, we are setting up Twitter profile verification, and you can see here some steps. So these steps are controlled by our browser extension. First one here, start page, allows us to specify the starting page where the user is redirected for the first time. If for some reason this is not working because somebody is not logged in or for some other reasons, we are handling authentication with the expect URL. So this is the URL to which user gets redirected if the start page is not working. And finally, we have the most important thing, which is an authorized call. And here we are actually connecting to the API endpoint that contains data that we want to be proven. To find the right endpoint for your data source, the easiest way is to manually use Network tab in your browser's DevTools while performing the actions you want to verify in the destination service. So for example, here on Twitter, you can just go to settings.json and, for example, prove that you are owning a certain Twitter handle. However, if you want to prove different things like Twitter details or if you are following somebody, then you have to spot here some other endpoint that contains data that you would like to use and prove in your application. Now, once everything is configured, let's obtain a web proof in our application that runs at localhost 5137. Make sure that vlayer Chrome extension is installed. The extension will guide you through connecting to your data source, so we will have some redirects to the Twitter. And once this step is completed, it captures the API response that we specified. In that example, we are looking into settings.json endpoint. And to verify that proof was actually captured correctly, just open Developer Tools, go to the Application tab, and under local storage, find the web proof key. And this key contains your cryptographic proof data that we're gonna use in the next steps. And before I jump into the code, I will just finish the minting part. And finally, the NFT is minted because the zero knowledge proof is correct. So in order to transform our web proof into a zero knowledge proof, we need to send it to our prover. It is very important to notice that we are using here vlayer SDK and we are sending the web proof not to the regular blockchain, but we are sending it to our ZK EVM that knows how to run vlayer provers. And here you can see, for example, that we can specify a data URL inside our smart contract. Then this data URL is verified in the body of the function. And finally, we are extracting the Twitter handle and we are returning it from the prover with the proof. That proof with screen name and account has to be used in order to call the verifier contract. So maybe let's take a look at the verifier contract. And here on the argument list, you can see exact parameters. We have proof, username, and account. We also have an only verified modifier that makes sure that the proof is correct. So if you pass a wrong proof or wrong inputs, then basically the verification on-chain would be failed. And now I think it's worth to take a look again into JS code. It is a regular WAGMI syntax for writing contracts. So we have to specify address of our deployed verified contract, ABI, function name, and then args, which are returned from our SDK. So if you are calling the prover, then our SDK returns you a proper arguments that you can just pass to your verification contract. Whenever you change your prover or verifier contract code, it's very important to remember to actually rebuild contracts and redeploy them to the testnet or devnet. And that's it for this tutorial. You now understand how to set up, configure, and implement web proofs to make web data verifiable on-chain. If you want to learn more, check out our docs and join our Discord community. Don't forget to like, subscribe, and comment with any questions. See you on the next one.